very straightforward constructions. And well, hello to everybody. And this morning we saw quite nice pictures from big dishes from the 1960s at the first EME tests. And subject of my presentation is, as Michael mentioned, the lower part of the scale, as many people now use dish sizes between 2 and 3 meters. And since a couple of years, I'm owner in my home QTH also of a former 2.8 meter dish and a former 2 meter dish, and then stepped up to 3 meters. You see it on the first photo. The story behind this that years ago I saved a 2 meter dish with F2D 0.6 from scrap, and that one was a solid dish. I removed the panels because I mainly wanted to use it on tropo for terrestrial QSOs, and I'm in a windy location, and I replaced the panels by 8mm mesh, and yes, the F2D ratio is a little bit low for that type of a feed. It's the RA3AQ feed, which I use at the Beacon as well, and had very good experience with it. And I did not want to go to different feed because I have the option here to add maybe sometime 70 centimeters with the 4 dipoles around we saw at the lecture before. Well, as you can see, there is also elevation control included already, because also my main intention was using it on tropo. In the back of my brain, I always have the feeling I must try every antenna I use for EME a little bit, and so it happened. You see here already the solid-state power amplifier. I didn't have it from the beginning. My first tests I made with only 15 watts at the feed from a Mitsubishi module. And surprisingly, I saw with this 2.8 meter dish immediately on spectrum waterfall graph my own echoes. So the next step was to try some JT QSOs with the bigger guns, also successful. And 2 years ago in the ARRL contest, I had one highlight. I called several stations on CW, random without SCAD, and DL0SHF heard me, so I made a QSO with him on random, and I was happy with it, but not really happy, because when I compare my results on JT with others, I found out that, for example, John PA7JB, he's here, I guess, yeah, he should feel guilty because he made me unhappy. I always was, when I recalculate his dish size to my dish size, always some dB in front of me, and that's not good. So I was thinking about what could I do. Furthermore, extension was not possible because, as you can see on the photo, the lower part is not possible to extend it because of the ropes here and so on. Then I remember that also RW3BP, Sergei, had very good success with an offset dish. John is also using an offset dish, so this must be the solution. To change completely to an offset dish would not have been possible. I would have replaced this dish. So one day, after looking up to the antenna many times, I had the idea to only extend the upper part of the dish and leave the lower part as it is. That was the present situation, 2.8 meters as mentioned, and 12 ribs only. And I also made, for comparisons before the modification, some sun noise measurement. 23 centimeter, 5th of July last year. Solar flux, 10.5 dB sun noise, can be very good, can be very bad, whatever. I compare it with the results after the modification. If you extend the dish size in whatever direction you want, you have to follow the parabolic curve. And this is what I did. The red colored part is what I extended. And you see, I had only 5 of the 12 ribs to extend. This is only maybe 20 or 30 centimeters. So really to extend, I had only 3 of them. And of course to make a new rim outside. The lower part of the original dish is obsolete by principle, but not really obsolete because it acts as a screen from ground noise, and on transmit it contributes for sure some tenths of a dB. Not much, but a little bit. So that's the new situation. The effective diameter is now 3 meters because I extend from 1.4 meters, 60 centimeters up, resulting in 2 meters, and effective for radiation is only used 1 meter at the low part. Well, sun noise measurements, you see here the original value, and after the extension, I had only 1 dB more. In reality, it's maybe only half a dB more because also I've done it within a couple of days. Solar flux raised, and that's the reason for that is the dish with the feed horn radiating in the original center will not hit the upper part a lot. And the real advantage showed up when I tilt the feed. That's the situation before tilting, and now I tilt the feed upwards by 25 degrees and radiate in the new center of the dish about half a meter upwards. I did not test other angles 20 degrees or 30 degrees because I was very happy with the result I got after. You see both old values, 2.8 meter dish 10.5 dB with 85 flux, 1 dB up, and now with tilting the feed, 2 dB more sun noise with slightly more solar flux. I can measure within 0.5 dB, I guess. I was very careful to have the sun always in the same position when I measure, because in that case I can eliminate the radiation I get, the pollution I get from the noisy town around. Well, this was promising, and you see a photo here. By the way, it's looking a little bit ugly, I must confess. But later on you will see other photos which I like more. And on transmit, it's of course harder to say what the improvement is. So sun noise, of course, on receive is not the very best method to measure gain, but it's at least you can see what was the improvement. On transmit from calculation, I think I get 1 dB at least more because I have more surface, slightly larger dish. Larger dish is always good. Slightly larger dish is a little bit good. So on the other side, I have now less blocking by the feed because it's out now of the center of radiation. By the way, I made SWR measurement, and I got, with the feed alone, around 25 dB return loss. Could be better, but okay. Then with the feed inside the dish, I got only 18 dBs, so there's still some reflections into the horn. But what I did is cut off a few centimeters from the transmit cable, and now I have 30 dB of return loss. So no secret behind this. Yes, so altogether, I think I have 1 dB better transmit at least, and I made many tests with own echoes, and I can reduce the power by 3 dB, 10 dB, whatever I want. And from the tests before, comparing with the tests after the modification, I can say I have at least 3 dB better echoes now. So when I have 2 dB better receive, my calculations with 1 dB better on transmit will be quite correct. On receive, we have additional improvement, 2 dB because, instead of 1 dB, because of, mainly I think because of less noise pickup from the ground. The feed is looking upwards. So, strength of own echoes is 3 dB better. Well, and I measured it, as I mentioned, with averaging, and even more impressive to me was that before the modifications, I could hear my own echoes with the 500 watt solid state power amplifier all the time, but I'm used to very weak signals, listening to very weak signals. When I ask my wife, come, listen to the echoes, she hears nothing. And after the modification, I got better echoes, so I call her again, come, listen now to the echoes. Yes, I hear. So probably even a little bit more than 3 dB. So the dish is XYL proof, and yes, these are the promised photos, looking better now. And here I have 25 degrees elevation. Because of that, the feed horn is exactly horizontal. And, well, we can play echoes I have recorded. Wait a moment, hope it works. Now a weak one. Yes, you can see even CW QSOs are possible quite easy. And I was awaiting the ARRL contest last October, November, or December, don't remember, and really tried what is possible with a small dish with this modification at the time. And the QSO result was quite good. I was only QRV CW and no logger or something like that, no scats, only random QSOs, and I could make 69 QSOs. And even more satisfied I was with the receiving results, as I heard slightly more than 100 different calls. Some I could not work because it's the problem between the little pistols. The little pistols work the big guns and don't work each other because it's always the QSO frequency, the CQ frequency of the partner. Not always, but very often. Well, so I consider that project as successful, and I even have a little bit more, not in the proceeds, but further plans, and that will be a 7.3 meter dish, and I also will go for a semi-offset. Of course, a true offset is even better, and the semi-offset is somewhat a compromise. But mechanical-wise, engineering is for a true offset dish is, I think, quite complicated if you want to do it with a 7 or 8 meter dish. And so I have less problems with the semi-offset, I expect, and still have big advantages. And the biggest advantage, in my opinion, is I will have easy access to the feed point. On that occasion, I remember a talk with Sergey, RW3BP, in Florence 4 years ago. And we were discussing already advantage, disadvantage of offset dishes, and he mentioned that with more and more years, you get less and less physical strength. And Michael, you are right, I'm physically in good condition now, but I do not know how I will feel in 10 years, and when I look around here, it's not only me who could have the same problem. So that's the main point. I can reach the feet from standing on the ground. And with the semi-offset, I've still reduced ground noise compared to a conventional prime offset dish. So what I did is first write some piece of software to calculate the ribs. All the numbers might be a little bit puzzling, but I can explain. I can choose the number of ribs, focal length, how deep the dish should be, and I can shift or not shift the center upwards. In that case, it's a conventional dish, so the center is not shifted up, and you see the results. You get axis or diameter 7.2 meters, and therefore, because of the focal length of 3.6, you get F to D ratio 0.5, so not really something new. And you can see every 20 degrees the form of the ribs on the vertical scale, and all ribs are the same, 4 millimeters, 17, and so on, in a diameter 250, 500 millimeters, and so on. And the length of the ribs is 3.6 meters everywhere. This screen is only for comparison. Now I have the values for an offset dish, semi-offset dish. I shift the center upwards from the original center by 2.2 meters. Then the feet comes down, and being originally, of course, 3.6 meters up in the middle of the dish, I think even Stanek cannot reach. Now feet came down to 1.5 meters, around 1.5 meters, and so it's quite comfortable even for short people as me. So the same, you find then the situation, you have to tilt up the feet by 40 degrees in that case. So it's closer to an offset dish than my present semi-offset. And in that case, I really expect less noise pickup. Well, I started this project already, and you see the different lengths of the ribs, also the different shape. And, well, it will take me another 1 or 1.5 years until all is completed. And I don't know yet if this project will be successful. If yes or no, I can tell you at the next EME conference. Thank you for your interest.